Welcome to hole number 2 of the Adventure Golf Course. Before starting this video, please make sure you go up to my front board and mark that you are on hole number 2 beside your name. That way I can keep track of where we are. Today's video, you're going to be defining a series of words, but you're actually going to define them with diagrams. So we'll go through quickly. I will show them. You should draw the diagrams on your guide to the course, and then we will finish with about 2 minutes and 30 seconds of a video, and you will write a response to that video before pulling the homework sheet off of the website. If you look, these are the vocabulary words that we will be defining: angle, vertex, acute angle, obtuse angle, right angle, straight angle, complementary angles, supplementary angles, adjacent angles, vertical angles, and congruent angles. Many of these terms should look familiar to you from previous year's study of geometry. An angle and vertex. If we look at this slide, point C is the vertex of this angle. We can name this angle ECD. We can name it angle DCE. It doesn't matter which ray I start with. If I start with CD or CE, what matters is that the vertex is in the center and that my naming letters are actually in order: ECD or CDE, or I'm sorry, DCE. We can also name this as just angle C. We can name it just with the vertex. This is typically okay if you have an angle that's standing by itself. If you have a large diagram with many angles, it's easier to name it with all three letters. But the vertex, again, would be C, the point at which the two rays come together. Acute, obtuse, and right angles. This is a right angle. You can see it forms a 90-degree angle. An acute angle is right here. Acute is anything that is less than 90 degrees. So that would be your acute angle, less than 90 degrees. An obtuse angle is an angle that is greater than 90 degrees but less than 180. So you can see if this were 90, it'd be coming up about right here. It's clearly greater than 90. So that is an obtuse angle. And a straight angle, if I actually put points on and name this ABC, ABC is actually a straight angle because the angle formed is 180 degrees. If you see an M in front of the angle symbol, that just means the measure of angle ABC is equal to 180 degrees. Here, if we call this DEF, this right angle, we would say the measure of angle DEF is equal to 90 degrees. Here, we would say the measure of this acute angle is less than 90, and the angle of this obtuse angle is greater than 90, but less than 180. Complementary and supplementary angles. This is talking about two angles that are adjacent to each other, which means they share a side, that add up to either 90 degrees for complementary or 180 degrees for supplementary. And the way I can remember which is which is C comes first in the alphabet compared to S. So 90 in the C come before 180 or the S. If I look at these two diagrams trying to decide which is which, this would clearly be supplementary because this angle and this angle combine to form a 180-degree angle. So this angle here and this angle here would be a pair of supplementary angles. These two angles add up to 180, so I can just simply take 180. I can subtract the angle that I know, which is 72 degrees, And I know that this angle, the measure of this angle here, is 108 degrees. Complementary angles, two angles that are adjacent that add up to 90 degrees. I can do the same thing, 90 degrees, subtract away the angle that I know, 42 degrees, and I'm left with a 48 degree angle. So for your diagram, supplementary would look like this, two angles that add up to 90, or up to 180. And complementary would be two angles that add up to 90 degrees. Adjacent, vertical, and congruent angles. I'm going to start with congruent. Congruent are two angles that are exactly equal to each other. If I look at this diagram, angle 3 is exactly the same as angle 1. So I would say angle 1 is congruent to angle 3. Angle 2 and angle 4 are also congruent to each other. So those would be pairs of congruent angles. Vertical angles are angles that share a vertex and are directly across from each other. So 1 and 3 are vertical. 2 and 4 also share the vertex and are across from each other. So in this case I have two pairs of vertical angles. And I think about a vertical leap being how high somebody can jump, and vertical angles are jumping across the vertex. It's my little trick to remember. Adjacent angles share a vertex and share a side. So angle 2 and angle 3 would be adjacent to each other because they share the side and the vertex. Angle 1 and angle 2 share, let me switch colors, share this vertex and the side. Angle 1 and 4 would also be adjacent because they share a vertex and the side. And angles 3 and 4 share a vertex and share a side. So adjacent, in general terms, in math, anything that's adjacent basically is something that's beside. Adjacent means beside. Okay, we're going to watch just a bit of this video, and we've done this in class, so this is really a review, but we're going to watch about 2 minutes and 35 seconds on how to measure an angle.
Hello and welcome to my video on how to use a protractor. Protractor is used to measure the amount of angle, degrees in an angle, and it is made up of usually a hole or a notch which you place over the vertex of the angle. The 0-degree line, which is at 0, or going to the left at 0 degrees. You'll notice there's two sets of numbers. You use the number that represents your angle. So if I'm over here at 120, that will be if it's an obtuse angle, and 60 across from the 120 will be if it's acute. So knowing that, let's try to measure an angle. What I have here is an angle, which I can measure from this side, or I can measure from this side. Now, if the lines are too short to reach all the way over to where you're measuring, you can always extend the angles, because rays go on forever. Just make sure that you're very much in line with the existing ray. and extend it as far as you wish. Once you do that, then it'll be easier to read. So let's put this vertex inside this hole to view it. I've got the vertex right inside the hole. Now let's get this ray lined up where it's right on the 0 line. The more accurate I am, the more accurate my measurement will be. There. This ray is in line with the 0-degree line. The hole is over the vertex, and all I have to do is go up here and read where it goes. Now I have to choose, is it 110 degrees or is it 70 degrees? Well, this angle is obviously larger than 90, so it's not acute, it would be obtuse. So it has to be more than 90. So it must be the 110. So this is 110 degrees. Now if I want to be sure, I can measure from this ray. All I have to do is extend the other ray as most.
Okay, now you are ready to print out your second hole scorecard. Go ahead and send it to the printer. Show me that you have your guide to the course ready. You can go down and grab it and you can start working on that.